Welcome you all to the week 6 problem solving session of Basic Calculus 1. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of fractal geometry and dynamical systems. In this problem solving session, we start doing the illustration that are based on derivative, and then we move to the applications of derivative in the form of how one can find the maxima and minima of a function, then Rolle's theorem, then mean value theorem. So let us start with the illustrations that are based on derivatives. Find the derivative of following. First one is y is equal to secant of 10x. So we have to find out the derivative of secant of 10x. So to do this, it is well known that derivative of secant x is secant x into 10x, and the derivative of 10x is secant square x. Now here if you will observe, this is kind of composition of secant and 10x. So that means we need to calculate the derivative of f of g at x, and by chain rule this is nothing but f dash g of x into g dash of x. This is, you can say, by chain rule. So let us apply it here. How? We will need to calculate secant of 10x. So let us follow it exactly as we have written in the above line. So what we do? We do the derivative of f with respect to gx. So we do the derivative of, if you will write it in the form, d of 10x and secant of 10x. This is what it means. And the next one will be d of 10x divided by d of x. So I'm writing just for simplicity. So what it will give you, this will give you, since this and this independent variable is same, so we can directly apply this differentiation definition. So this will be 10x, while when you do the derivative of here, the angle is 10x and 10 of 10x. So next one will be secant of square x. One way is to see like this. Another way to see like this, you can do directly, that is treat this 10x like normal x. Then what will be the differentiation? Secant x and 10x. And what is in place of x? 10x. So you just need to write tan of 10x. Now since you have treated or assumed that here it is x only rather than 10x, then you have to do the differentiation of the new term or the new angle, that is 10x, and this will again give you 10x tan of 10x into secant square x. I hope it is clear to everybody. So let me give you one more. R is equal to cosec theta plus cot theta inverse. So how to deal with it? Here, if you will observe that, you know that d over dx of x to the power n is nothing but nx to the power n minus 1 when if n is not equal to 1, only when. Next one is d over dx of cosec x. What is its differentiation? Minus cosec x cot x, and d over dx of cot x is minus cosec square x.
Sir, if n will be equal to 1, then what will happen?
Wait a second. Did wrote something wrong? Sorry. There is no need of this, I guess. That is in case of the integration.
Yes, sir.
So in this scenario, there will be no problem with this. I thought something integration like. So next is now we have to apply the chain rule here. dr over d theta. Here is independent variable is theta. So if you will see, there is a function whole inverse is there. So what we do, we treat it as x. This term as we treat it as x. Here it is theta, independent variable. So we will treat it as theta. So what is the just a second. You try at home, then we will discuss. Sorry for the interruption. So we were talking about how to do the derivative of this. So we will treat it as theta. And what is the differentiation of theta to the power minus 1? So it will be minus 1. And in place of theta, we know that it is cosec theta plus cot theta and minus 1 minus 1. Next, since we treat it as theta, then we have to differentiate it also with respect to the its independent variable, that is this one. So it will give you minus 1 into theta plus cot theta to the power 2, and the differentiation of this is minus cosec theta cot theta and minus cosec square theta. So from here, if you will take cosec theta out of it, it will give you plus cot theta. Is it fine? The same answer you were getting?
Yes, sir.
Okay. So
Same answer, sir.
okay. Then we have given, I'm giving you some.
Sir,
Okay, yeah.
sir, sir, we can apply a shortcut also, sir. If we just multiply theta minus cot theta, it will get simplified. Very simplified, matlab, sir. cosec square theta minus cot square theta equal to 1. So we can simplify that.
Where?
Sir, in the previous question, like before applying this rule, if we can multiply cosec theta minus cot theta.
Understood. We can do that also. So next one is x tan 2 under root x plus 7. D part is qt sin t divided by under root of t plus 1. So these two we need to do now. So let us give a space a little. Okay, so let us try this one. What will be the derivative of h dash x? So it will be d over dx of this h of x, which can be written as d over dx of x tan 2 under root x plus d by d of 7. How I am writing like this? On which rule? By
Sir, distributive property.
algebra of limits. In general, we call it as algebra of limits. You have wrote algebra of derivatives, or you can say rules of derivatives if you're not comfortable with this terminology. I hope you have watched the lecture rules of derivatives. That means you can take out the scalar multiplication, you can distribute them. It's a kind of obviously distributive property, but you are just explicitly doing by the rules of derivatives. So what will be the differentiation of this first term? By product rule, you know that tan 2 under root x will be as it is, d over dx of x, plus x will be as it is, d over dx of tan 2 under root of x, and the last term will be 0 because the differentiation of constant is 0. So what will be the derivative of the rest of the term? This will be tan 2 under root x, and the differentiation of will be 1 x to the power 1 minus 1, plus you know that here it is not x. So what you do for the time being, you will assume it x and apply the chain rule. So secant square 2 under root x and d over dx of 2 under root of x. So this will give you this is nothing but 1. So tan 2 under root of x plus, and this 2 under root of x will give you, here it is 2x secant square 2 under root of x, and this will be half x to the power half minus 1. So if you will simplify it a little, you will get tan 2 under root x plus 2 and 2 will cancel out from here, and you will get under root x in the denominator, and it will give you under root of x secant square 2 under root of x. Is everybody is getting the same?
Yes.
Okay. So now this last one, q dash t. Again, it's a differentiation of sine, and there is must be some different term rather than t. So you have to apply the chain rule. So this will be cos t under root t plus 1, then the derivative of this left term that is used as a chain. So this will be cos t by under root of t plus 1. So here we try to apply the quotient rule. So what it says this will be under root t plus 1 whole square under root t plus 1 d over dt of t minus t will be as it is d over dt of under root of t plus 1. So this will give you cos t by under root of t plus 1, and this will be under root of t plus 1 minus t. Again you have to apply the chain rule to under root t plus 1, so it will give you half under root t plus 1, or in fact I should write half minus 1, and the differentiation of t plus 1 is nothing but 1 divided by t plus 1. So this will be, now let us simplify it a little. So this will give you 2 times of t plus 1 minus t divided by t plus 1 to the power 3 by 2 cos of t by under root of t plus 1. So this will give you t plus 2 divided by t plus 1 to the power 3 by 2 cos of t by under root of t plus 1. Is it fine? So
Yes, sir.
the last one in this question is 10 to the power 4 t by 12 to the whole power cube. Try this one. Okay, tell me how we should do it.
Sir, firstly, we will see it as x cube.
Okay, so it will be 3 1 plus the rest of the x, that is this one, to the whole power 3 minus 1,
2,
12,
1.
1 plus 10 4 t by 12, right? So
Yes, sir.
let us simplify this a little. 1 plus 10 4 t by 12 2. Now differentiation of 1 will be,
0.
and differentiation of the other term will be,
4 into 10 cube t by 12. And sir, d by dt of 10, 10 of t by 12.
okay. So since we are treating at x to the power 4, so the left x will be here 10 t to the power 12. 10 t angle with angle t by 12. So this will give you, if you will solve it, 12 10 q t by 12 1 plus 10 to the power 4 t by 12 q, and this will be secant square t by 12 d over dt of t by 12. So from the last term you will get 1 by 12, and 12 12 will cancel out, and you will left with secant square t by 12 10 cube t by 12 into 1 plus 10 4 t by 12 cube. Is it clear?
Yes, sir.
Okay, till now you know how to do the explicit differentiation. This is the explicit differentiation. What will be the implicit differentiation? You know the explicit function or implicit function meaning?
Yes, sir.
What is it? What is that?
Sir, in explicit functions, we can represent a function in terms of independent variable, but in
Okay.
explicit, we cannot like separate them.
Okay. So now we can do some problems over this explicit or implicit differentiation. So I am writing some problems. You will try first at your own, then we will discuss it. Find the implicit differentiation. First one is x plus 10 xy equal to 0. Second one is y sine 1 by y is equal to 1 minus xy. And third one is under root theta plus under root r equal to 1. So here you have to find out dy by dx, dy by dx, and you have to find out dr by d theta. So these three are examples of implicit function where you cannot separate this y dependent variable in the form of independent variable function. So the method is simply same. You need to apply the derivative on the both the sides, and you need to use the rules of differentiation and calculate these derivatives. So first you try at your own, then we will discuss it after a break. uh, with this I am writing one more question, then you do both of them, then we will discuss. Find the tangent to the curve y is equal to 210 pi x by 4 at x equal to 1, and the other part is what is the smallest value of the slope of the curve on the interval -2 to 2. Give reasons. So we will discuss after a short break. Till then you can try these all.
Sir,
So any answers?
yes, sir.
So
Sir, for the first one, it is 1 upon x into minus 1 upon x into 1 upon sec square of xy.
for the first one, minus 1 upon x. Okay.
Yes, sir. Into 1 upon sec square of xy
Hmm.
plus y.
Okay. Second one,
Sir, for the second one, it is minus y upon sine of 1 by y minus 1 by y into cos of 1 by y
there will be, I
plus
think,
1
minus y square.
minus y square.
Your y or minus y square? What is in your answer?
Sir, y.
Y. So I think it will be minus y square. So let us see. So let us start with the first one. So as I told you, we have to differentiate both the sides. So what we do, d over dx of d over, so this will give you 1 plus secant square of xy d over dx of xy, this will be 0, 1 plus secant square of xy, and this will be x dy by dx plus y, and from here what you will get, x dy by dx minus cos of xy minus of y, so dy by dx will be minus cos of square cos square xy plus y divided by x. Is it the same? So the next one, in this we have y sine 1 by y. Now Archit, see here. So from here, when you differentiate both the sides, first of all, sine 1 by y will be as it is, dy by dx plus y as it is, cos of 1 by y d by dx of 1 by y, and from here this will be 0 minus y as it is into 1 and minus x as it is dy by dx, and from here sine 1 by y plus, from here you will get minus 1 by y square. So this will contribute as on whole the term cos of 1 by y divide by y, and from here you can take dy by dx out of it, and this will be y minus x dy by dx. So this will be dy by dx y square divide by from here you will get y sine, just a second, sine plus xy, and the negative sign cos of 1 by y. So is it the same answer you are getting, Archit?
Yes, sir, it's same. I have not taken the LCM.
Okay. So what about the last one? So the C part.
Sir, minus of under root r upon theta.
Okay. So this will be 1 by under root of theta. We know that our equation is under root of theta plus under root of r equal to 1. So this will give you 1 by under root theta, since independent variable was theta. So here 1 by 2 under root of r dr by d theta equal to 0, and if you will simplify it, this will give you minus under root r divided by under root of theta. So I hope it is clear to everybody how to find out the implicit differentiation. Now what about this third one? What is the equation of tangent line? First of all, what is the slope of this line, tangent line? So dy by dx is?
Sir, pi. Slope is equal to pi, and sir, equation is y equals to pi x plus 2 minus pi.
Correct. So this will be 2 times of secant square of pi x by 4 and d by dx of pi x by 4. So this will give you dy by dx pi x by 2 secant square of pi x by 4. So dy by dx.
Sir, pi by 2. Sir, not pi x by 2. Pi by 2, sir.
Only constant will come out. So this will be,
Yes, sir.
at x equal to 1. This will
Yes,
be
sir.
pi by 2 secant square of pi by 4. What is the value of secant pi by 4? 1 by under root, only under root 2, and its square, so it will give you
Yes, sir.
pi.
2.
Since x equal to 1, what will be the value of y at x equal to 1? This will be,
Sir, 2.
2 times of 10 pi by 4, that is
Pi by
2.
4.
So you know the point 1 comma 2, you know the slope of line m equal to pi. So what is the equation of line? This will be y minus 2 into the slope of line into x minus 1. So this will give you pi x minus pi plus 2. Now in the next part, you have asked that what is the smallest value of the slope in interval. So this interval, this is the interval. So let me write it on the interval. So you have given the range, or you can say domain of x. So what was your dy by dx? It was pi by 2.
Sir, pi by 2 into sec square of pi x by 4.
And your interval is given
Minus 2 to 2.
So you know that this secant square pi x by 4 is always greater than equal to 1.
1.
So we have been asked that what is the minimum value of this loop. So
Yes,
its
yes sir.
minimum value will be 1 obviously. So minimum
Yes sir.
value of pi x by 4 is 1, and it will be attained at when it will be,
X equal to 0.
so x will be 0. So at x equal to 0 you will get the minimum slope, and what will be the value of that minimum slope?
Sir,
Minimum
it will be pi by 2.
slope will be pi by,
Sir, if the domain is something different, then how will approach, sir?
like,
Like, sir, if it is started from 1, 0 is not included in the domain.
if 0 is not included in the domain, suppose it is from 1 to 2, right?
Yes, sir.
So what is the graph of sec x? Like this. At 0 it is 1, at pi by 2 it goes
Yes,
to
sir.
infinity, and minus pi by 2 it again goes to infinity. What is the value
Yes,
of
sir.
pi by 2? This is something 1.54 something,
Yes, sir.
57 I mean.
Yes, sir. 5, 7.
and and 2 will be something like, so we have to just first check. You are talking about x lies between 1 to 2, so your pi
Yes,
x
sir.
by 4 will lie between pi by
Pi
4
by
to
4 to pi by 2.
pi by 2. So your interval will be this pi by 4, suppose here in between, and this is your pi by 2. So clearly you can see that the function is values is increasing.
Yes, sir.
So where you will get the minimum value?
At pi by 4
At pi by
or
4,
x equal to 1.
x equal to 1, but its 1 is not touching. So you can tell
Yes, sir.
the infimum, you cannot tell that it will exact value of what will be that infimum. Okay, you can guess
Yes, sir.
the minimum, this will be bounded by this at this pi by 4, but you cannot tell the exact value. Okay,
Yes, sir.
if it is included, then you can say that it will attain at 1, and what will the value, you can tell it. Okay,
Yes, sir.
so till now we have seen how to calculate implicit, explicit differentiation, slope of the equation. So we have discussed all of this. Now what is the application of the derivative? So suppose you have given any function, so you with the help of derivative you can discuss its maxima, minima, and maximum minimum, it might be the local one or it might be the global one. So let me tell you first what is the local and global. Local minima, suppose this is your graph. What is the local minima? Suppose I am talking about this point. Local means you are searching in the neighborhood of this, and global means you are talking about on whole of the domain. So if you only search of the neighborhood of the critical point, then you will say you are discussing the local minima. And when you talk about whole of the interval or whole of the domain of the function, then it will be a global or absolute minima maxima. So there is a famous theorem for this, that is max min theorem for continuous function. So if f is continuous at every point of a closed interval. I hope you remember what is the closed interval. Comma, then f assume, or you can say f attain both an absolute maxima and absolute minima, and we are naming them as capital M, small m, and somewhere in I. Here I means this closed interval. So I'm saying if you have a continuous function and over a closed interval specifically, if those endpoints are not included, then we cannot guarantee. So then you can attain, then the function will attain its absolute minima and absolute maxima in that interval, or in fact on the corner points also. So the sum of the questions will be based on this theorem. First one is, okay, in between we have missed one question, then we will do after it. So this will be question number 4. So determine from the graph whether the function has any absolute extrema. What is extrema? Anyone? We did it in the
Yes, sir.
last.
It is the minimum upper bound.
No. Extrema I'm asking about. Have you remember that extreme value theorem? Extrema means it can be absolute minima, it can be absolute maxima. So I am giving you 3 graphs. In the first graph, the function is like this. This is your function. This is your A. This point is C1. This point is C2. And this point is B. From here, tell me what is its either. First of all, tell me absolute extrema is existing. If it is existing, at which point they are attaining, and is it not contradicting this above theorem, or if it is contradicting, then why? Understood my question?
Yes, sir.
So tell me the absolute extrema, whether it is existing or not.
Sir, it is existing.
Okay. What is the what are the points where they are existing?
Sir, at point C1 and C2.
At point C1 and C2. Okay. Absolute maxima will be at
C1.
absolute minima will be at now. Is it satisfying the above theorem?
Sir, can you tell like what exactly is the above theorem?
Read it out first. Have you read it?
Yes, sir.
So here they are saying if function is continuous on every point of this closed interval I, then absolute maxima and absolute minima will be attained in that interval. So here the function is continuous at every point of this domain A to B.
Yes, sir.
AB is a compact closed interval. You can see that.
Yes, sir.
So that means it must have attained its absolute maxima and minima, and that you are already telling them at C1 at some C2. Is it clear?
Yes, sir.
Now, what will be the case of like this? This is A, this is C, this is B. What will be the in this scenario? Does absolute
Sir,
min yes,
sir, absolute minimum will not exist and absolute maximum will be at point C.
absolute maxima will be at x equal to C and no absolute minima. Now tell me, is it consistent with the above theorem?
Yes, sir.
Why?
Sir, because the points are not included in the interval. It's not closed interval.
Good. So still it consistent, and obviously it was already consistent. Now let us discuss the last one. See, one graph is this. A, C and B. What will be in this case?
Sir, absolute extreme, absolute maximum will be at C and minimum will be at point B.
Is it consistent with the theorem?
Yes, sir.
Why?
Sir, because if we want to see it in context of theorem, then we have to see it from A to C. We can only apply in A to C, and in A to C we have absolute maxima at C and absolute minima at A.
And any other reasoning? If you see A to C, then the absolute minima will be at A.
Yes, sir.
See, the function is continuous.
Uh, no, sir. Function is not continuous at C.
And obviously you cannot apply that above theorem. So that means it is consistent with the above theorem, because it is not applicable, na?
Yes, sir.
So the question that I missed, let me do with that first. If x cube related to the implicit differentiation is equal to 16, find the value of d2y dx square at the point. Observe here, in case of implicit function, you will be given the both the points, although you can calculate it from the equation. So calculate the value of the double derivative at these point 2 comma 2.
Sir, this is an implicit function or an explicit function, sir?
You tell me.
Sir, I think it's explicit function.
Okay, it is explicit function.
Sir, 2.
No, there is a sign convention, minus.
Sir, sign convention.
Is it minus 2? Minus
Yes,
2.
sir, -2, -2. Yes, sir. I missed the sign, sir.
Hmm. So when you differentiate first time, it will be 3x square 3y square dy by dx is equal to 0. Since you want to differentiate again, so you can differentiate again. See, 6x 6y d2y by dx square plus, you have to apply here the product rule. Oh, there is an error. So this will be dy by dx whole square,
Whole square, yes, sir.
and then it will be 3y
3y
square
square d2y by
dy by
dx
dx.
square.
So obviously you need dy by dx at 2 comma 2 also. So from here dy by dx at 2 comma 2 will be -1,
Yes, sir.
and from here your d2y by dx square at 2 comma 2, this will be, so, minus 12 into -1, so -1 square, and divide by 3y square, that is 3 times of 4. So this will give you -2. Is it correct?
Yes, sir. Correct, sir.
My calculation way is a little different, so you don't get confused with it.
Yes, sir.
So the next application is, as I told you, the local minima. We will discuss that, or local extrema. So find the values of any local maxima and minima. The function may have on the given domains and say where they are assumed, and then which extrema, if they are existing any, are absolute for the given domain. So I am giving you a function fx is equal to x square minus 4, and I am giving you 4 different domains, in fact 5, minus 2 to 2, minus 2, open to, minus 2 to 2, minus 2 to infinity, and minus infinity, or at 0 to infinity. So this is your whole different kind of domains, and this is your function. You need to tell whether over these domains, each domains, tell me the local minima or local extrema existing, and if it is existing, at which point it is attaining, and out of those which of the one is absolute extrema. So try.
Sir,
Yes.
sir, in the first case, sir, at -2 and 2, local maxima and absolute maxima will be attained, and at 0, local minima and absolute minima will be attained.
Okay. So, how did you approach this one?
Sir, from the graph,
The easiest way to approach with the graph. Here it is a graph of x square minus 4. What is the graph of x square? You know that?
yes, sir.
Like this. This is a graph of, you need to draw minus 4. So that means you have to shift it below the axis. So here it is at 0. So it will be like this. Assume it is parabola. So here it is 0. Here it will be minus 2. And here it will be 2. So from graph itself, when you talk about the interval minus 2 to 2, so at this interval, can you tell me from the graph, from here it is starting until here it is going. So what is absolute maxima or local maxima you are seeing in this? Local maxima will be 0 and it will be attained at any value of this
X
number,
equal to +2 or -2, sir.
and local minima is
-4,
minus 4 at x equal to 0. And
0.
since it is a continuous function, it is over compact interval or closed interval, then it must attain its absolute minima or absolute maxima. And what is absolute minima?
Sir, -4.
See, it is absolute minimum value, that is minus 4, and that is attaining at, this is also value,
Value, yes, sir.
not maxima, means we are talking about the point. So next one is now what if I would take one point out of it, that is 2. Again the answer will be the same, just in the above
Yes, sir.
you have to exclude x equal to 2.
2.
You have to exclude this point. So I'm not writing it, you can do it at your own. C part, when we talk about open interval, then local maxima,
Minima will not exist.
yes, does not exist. If local minima does not exist, that means absolute maxima will also not attain,
Exist.
and local minima will be the same.
Yes, sir.
Next is
Sir,
minus,
sir, -2 to infinite.
then
Then,
minus
sir,
2 to infinite.
local maxima will be attained at minus.
What will be the local minima? This will be like here, minus 4.
Sir, at 0, same.
At 0 same, but no
Yes, sir.
local maxima. So no
No,
local,
sir. There is local maxima na, at -2, sir.
think about it. Will it be there?
Yes, sir. At -2.
How you can say that?
Because we are not taking about absolute.
Good,
-2 is, this is a closed interval, and we can say that it's local maxima, sir.
good. So local maximum value will be
0.
at at
x equal to -2.
now the last one is 0 to infinity. Now tell me, well, whether local maxima will exist.
No, sir.
So local maxima does not exist and absolute maxima also.
Will not exist. And sir, in this case, local minima and absolute minima will also not exist.
Local minima does not exist because 0 we have been excluded, and absolute
Sir,
minima will also
sir,
not
can we
exist.
take infinite, sir, infinite as local maxima or absolute maximum value?
No, we are talking about value in R. So infinity does not belongs to R. By how we write
Sir,
infinity?
infinity does not belongs to R.
We write like this, na? Open.
Yes, sir.
We don't write like closed. So infinity does
Yes,
not
sir.
belongs to R. So this is the graphical approach. How one can get in theoretical manner, mathematical manner. So you need to derivate and it will give you 2x.
2x.
What is the critical? What are the critical points? The critical points
0
are
at
those
x equal to
points
0.
where the derivative is 0 or where the derivative does not define. So here if you put f dash x0, so it will be 2x0 and x equal to 0. So that means x equal to 0 is a,
Critical point, sir.
but whether the function does not define at any point. Is there any points
No, sir. Function is defined at on R.
on R? So that means there is only critical point, that is 0. So around this you can discuss that local minima, local maxima things. But when you talk about absolute minima, absolute maxima, you have to take consider the endpoints also. This thing does not discuss anything about the endpoints because the derivative concept is two-sided one, not one-sided. Okay, this is only valid in the interval. Over any closed interval, if you are calculating, you are talking about in the interval. Okay, so
Sir, in critical point, what points we will check, sir? Sir, first, so when it will be 0, and sir, second, what you said?
the points, endpoints, like here's the interval -2 to 2. So you need to check at -2 and 2 also. One is at interval this, when at x equal to 0, that is a critical point, and another critical point will be considered this -2 and 2 endpoints of the interval. Okay, you see,
And sir, you said like where the function is not defined.
derivative is not defined, function is not defined. I'm not saying derivative is not defined. There are some points where the derivative is not defined. That points are also considered as critical points. Okay, so next is the theorem for local extreme value. So let me write this theorem. The first derivative theorem for local extreme
Yes, sir.
values. What is this theorem
Yes, sir.
says? So this states that if f has a local maxima or minimum value at an interior observe here, we only talk about interior point C of its domain, and if f dash is defined at C, then only we say that its derivative at C is 0. So I am talking about that at an interior point, if we know that our function is differentiable at that point, and local minima, that point is corresponding to local minima or maxima, then derivative must be 0 at that point. Okay, this is kind of, you can say, how one can find out the critical points. This is theorem belongs to that. So on behalf of this, I am asking you one question, that the function fx equal to mod x I am giving you has an absolute minimum value at x equal to 0, even though f is not differentiable at x equal to 0. Is this consistent with the above result, or in fact above theorem? Tell me this one.
Yes, sir. It is consistent with the above theorem.
Why?
Because, sir, in the theorem we have f dash should be defined at that point.
So what is the reason here whether it is not defined?
Yes, sir. Here it is not defined because in the right neighborhood we have it is derivative is equal to 1, and in the left neighborhood it is equal to -1, sir.
Can you prove it?
Yes, sir.
Do it.
Yes, sir. If we find the right hand derivative by the f of x plus h minus f of x upon h.
A second. Just a second. In this scenario, local minima is existing. Minus 2 to infinity.
Yes, sir. It. I think you are considering it. Yes, at 0 it is existing.
Okay. Just want to make sure you are getting it right. Okay. So tell me. So here, if you will observe that they are asking that, first of all, it is consistent with the theorem because our function is not differentiable at x equal to 0. So we cannot discuss it.
Yes, sir.
So that means there might exist some point. So this is the example you were asking me, na?
Yes, sir.
Where the function is not differentiable, why these points are considering it as extreme points or critical points, I mean. So
Yes, sir.
this is the reason why we consider the points there the function is not differentiable as an critical point. So if you will observe its graph, there is a peak at this x equal to 0. There is a line like this, there is a line like this, and in form of tangent, if you will say, then there must be a unique tangent. So if you will observe that from one side this is a tangent and from other side this is a tangent, can at one point there might can be at two tangents.
No, sir.
So
It is
function is
not
not
possible.
differentiable. So, and in terms of derivative form, if you will see, f of 0 plus h minus f of 0 divided by h. So this will be limit h tends to 0 of mod h divided by h. Again we know that this is minus 1 and 1 if we are approaching from the left hand side. So we are approaching h tends to 0 minus kind of thing, or let me write if h is less than 0 and if h is greater than 0. Fine.
Yes, sir.
So it is not contradicting, or it is consistent with the above theorem. Now let me write a different version. Question number 8. Why can't the conclusion of the above theorem be expected to hold if C is an endpoint of the function domain? Since we are discussing for the interior points only, so it has been asked why we cannot discuss of the endpoints of the domain. Think and then tell me. With Tell me with the concrete reason.
Sir, by example, so I can prove, sir.
What you can prove by example?
Sir, I can prove that the statement will not hold by giving an example like sir, y equals to x square, and if we take the domain from 1 to 2,
Mhm.
then sir, local minima is existing at 1, but f dash is not 0 at x equal to 1.
Hmm.
So by this,
Read the question. Read the question first. The question is not asked about that. You are, you are telling the example where local minima is attaining and the function is not differentiable. That is correct. But it has been asked why we don't consider endpoints. What can be the reason of that?
sir, because sir, like in differentiation, we always need some interval to find the change, and if we consider the endpoint, there is no interval in its neighborhood in the left hand side or maybe in the right hand side.
Now you got it a little right. Since the derivative requires a two-sided limit, and while at endpoint only one side limit exists. Is it clear?
Yes, sir.
So function can have extrema at the endpoints. That is why we also consider the endpoints while discussing the absolute extrema. But derivative may not be defined there. So example is fx equal to x on the interval 0 1. So f0 is 1. So here the minimum value is 0, that is at x equal to 0. But f dash 0 is 1, which is non-zero. So
Yes, sir.
it is not contradicting the above theorem, because in the above theorem we only talk about the interior point.
Interior point C.
Okay. So next one is if an even function has a local maxima at x equal to c. So can we comment anything for f at x equal to minus c? Can we comment? Think about it and tell me.
Yes, sir, we can comment as the function behavior will be same in the neighborhood of C and same to of minus C. So at minus C also there will be local maxima.
Since f of minus x is f of x for all x lying in the domain of f, therefore f will have a local maxima at here.
Yes, sir.
So
Sir, if we have to prove this in like if we have to prove this, then how we will approach, sir?
just a second. This is the proof itself. In general, you are saying this thing. Then obviously at C it will also the same, na? At C, what will happen? F of minus C will be f of C, and
Yes, sir.
you are saying there is a absolute local maxima at x equal to C. So now obviously there will be
Yes, sir.
absolute maxima for f of minus C also, no? They have same value.
Yes, sir.
So tell me for the odd function.
Yes, sir. We can say that it will have local minima.
So in this scenario, f of minus C x is f of x. So you were asking about the proof. If you will see, f dash of minus x will be, tell me.
Sir, minus times of f dash x.
Is there will be a minus sign?
No, sir.
No. Sure.
Sir, sir, minus times of f dash x. Sir, why there will be a minus sign, sir?
You will tell.
Yes, sir, because we have firstly differentiated with respect to minus x, then minus x with respect to x.
Is it clear, Nancy? Nancy?
Yes, sir, clear.
So, what is the benefit of doing this? That at x equal to c, this will be, so minus with c will also be a critical point,
Local maxima or minima.
critical point, and then it will also,
Critical point, yes, sir.
so it will give you a local maxima or minima. So in general, by definition, you can say that directly x equal to minus c corresponds to local minima of f. Correct? Now, how many of you know the statement of mean value theorem? Find C. So before doing this, first of all, which of the following satisfy the hypothesis of MVT, mean value theorem? A is B is just a second. I think there is some technical error, because of that the in between solutions are erased. So I'll write it again, but for the time being you do this one. Question number 12. Which of the following satisfy the hypothesis of mean value theorem?
Sir,
Yes.
sir, what is mean value theorem?
Um, after how much
Sir,
time?
I have checked, like, sir, I cannot remember, but, sir, I think, sir, that in the interval there will be a point whose slope of tangent will be equal to the slope of the secant from the endpoints.
Any other answers? Anyone other? Your answer is correct, but you need to think what are the hypotheses under which we talk it about. So mean value theorem is like this. Let be a function such that is f is continuous on closed interval AB on whole domain. F is differentiable on open interval AB. Then there exists a C between AB such that f dash C is f of B minus f of A divided by B minus C. So I'm asking whether the given functions satisfy the hypothesis of this MVT or not. Now try this. B will satisfy, A will not.
Sir, both will be consistent of the theorem, sir. Both will satisfy.
No. A will not.
No, A will not, sir.
No.
Sir, A will like, sir, like it cannot counter the theorem. It is the theorem will be not applied on A, but it cannot not satisfy, like, sir.
Think about it. Did you get the reason? F is continuous over this interval.
Yes, sir. F is continuous.
F is differentiable over open interval.
No, sir.
With uh, earlier you were saying that it is differentiable.
No, sir. I am not saying it is differentiable. Sir, I am saying that theorem is applicable here.
Theorem will not. These are the hypotheses. If these satisfy, then you can say theorem will be applicable.
Yes, sir. I got it, sir. I got it, sir.
So F is not differentiable at just a second. Therefore, F does not satisfy the hypothesis of MVT. Next one is
Under root x minus x squared. Yes, sir. X into x.
so first one is F is continuous on F is differentiable on 0 1. Observe here the points that can create the problem is 0 or 1. Both are excluded from this interval, so there will be no issue. So thus F satisfy the hypothesis of mean value theorem. Is it clear?
Yes, sir.
Yes, sir.
Okay. So there are two more questions that we will do continue in the next class, that are based on how to calculate the value of C in this from this MVT, and the one question is based on the Rolle's theorem. It we will do in the next class. Any other query?
No, sir.
Okay. Then let's meet on the next Tuesday, same time.
Yes, sir.